How's everyone doing? Um, so, for those that don't know, what we do here is we take news articles about breaches and turn them into structured results, which go into a data set called VCDB. I'm Gabriel Bassett. I'm a data scientist. I work on the DBIR team, but today we're just going to be coding some public data, and this data is available for anyone who wants to use it. Academics, researchers, organizations. It's on a GitHub that is available to all. In fact, if you want to see it yourself, you can see it at VCDB. We have both the schema we use. The schema is an expansion of the Varus schema. Varus is a JSON schema we use for encoding breaches in a structured way. It also has a couple other things in here. I don't think there's much in the bin. A couple of minor scripts to fix stuff. Most of the stuff is in the data. There's a CSV file of the flattened JSON structure. It works, but it's very large. It isn't really the greatest thing in the world to use. We have the R data frame, which is the equivalent of what we tend to use. And then there's the JSON, individual JSON files, of which there are many. We submit them into the submitted directory. A workflow on our side pulls them and validates them every night, and then puts them in validate, and then adds them to the CSV file. The joined JSON file, which is a single JSON file with a list with one JSON file for each record, which works better for things like maybe Tableau or such. And then the individual and the varusr object. And so that's our data set. But what we need to do is we need to go look at some of the 7,000 plus issues that each represents an individual breach that we've pulled from media somewhere. And we are going to turn it into structured data. And I have a bunch assigned to me, so we'll go look at the ones that are assigned to me, and we'll try to knock them off. I'm a bit behind. Got behind when we started we all went to DEF CON. And Black Hat and B-Sides, so I'm trying to play catch up. So let's start. By the way, a lot of sign happens on this because it turns out that most of the breaches we code are not exciting, interesting, amazing things. They are obvious, near painful things that happen over and over and over again. But maybe we'll get lucky and this will be a completely unique, interesting breach of novel consequence that the attack or the defenders really should have been able, or didn't have a whole lot of chance to stop it. They're very hard to attack to stop. Oh, come on. Data security enthusiast who goes by the name of Gareth on Twitter pointed out that Rupee Reedy was leaking customer details because of some vulnerability on its cloud storage facility. Well, the first one isn't going to be that fancy attack. This is going to be someone left their cloud storage open to the internet. And that happens a lot. If you've read the previous DBIR, you would know that. Well, let's get started. Do we have enough information to code a breach here? New age data-driven technology companies, that's padding. Ruby discovered vulnerabilities on its data stack. Probably using the word vulnerabilities pretty loosely there. A data security enthusiast who goes by the name of Gareth on microblogging site Twitter, for those that didn't understand what it was, pointed out it was leaking customer details because of some low cloud storage. We can access was customer scan copies of ARDAR or PAN cards, which are usually submitted by applicants during KYC. So they explained what Twitter is, but didn't spell this out. Okay. On being pointed out after the same redacted files were put out in the public domain, the company swiftly got the leak sealed, helped by professionals by late Friday. So we've got a date, we've got a company, we've got an asset, we've got a discovery method. We have probably an action, which is going to be error. Potentially isolated vulnerability in one of our data storage block was brought to our attention. Thankfully, the vulnerability was recognized and fixed within hours of being recognized, not of probably being exposed. Preventing the compromise of our system or data is noteworthy that we've been audited and they didn't catch this, so therefore it's not our fault. There's always something in the articles where the victim is, it says something that's like it could have been worse. We weren't as completely bad, right? We passed an audit, or we closed it in hours. Maintain high standards. Part of the digital financial international Moscow-based financing entity, and it's in the very early stages of operations in the country. So, this is going to be an interesting company to try to figure out. It looks like a company owned by a Moscow company to do finance in India, maybe. As per its website, the company facilitates instant personal loans through its platform and offers a rate of interest of only 0.0882% daily. Wonder what that compounds to. A few months back, another digital lender. Okay, so this is payday loan website. Okay, well, let's give this a shot. It'd be nice if they linked to the actual Twitter tweet by whoever this user is. Maybe we can find it. Go check it out on another screen and see if it's anywhere usable. This is Rupee Reedy. Okay. Now that tweet doesn't work. It looks, and there's a bunch of cached tweets that do not seem to be flattering of Rupee Reedy's response. It is certainly an open S3 bucket. Okay. So the first thing we need to do is we need to put in the issue number. And this is for backwards traceability, since we limit the amount of backwards traceability from the structured data to the unstructured, or to the source data, to make it less likely that something will be slipped through. Open cloud storage. That kind of explains it. Timeline. So it looks like he discovered it sued by professionals late Friday, and they said they sealed it within a few hours, maybe. Sort of January 18th. The tweets where he was talking about it on January 18th. So if we go back and look at January, this is a 2019 article, yeah. 18th. January 18th was the Friday. So we'll say that the incident happened 18. Compromise. In minutes, it was just discovered. Exfiltration. It's basically involved in compromise because the guy who discovered it downloaded a bit of data. Discovery. Probably minutes. He informed them about the issue, and containment happened in hours, according to this. And then notification, really didn't happen. They didn't really talk about it. The company didn't. Victim ID is, I guess RupeeD is the appropriate organization. Do we know much about them? Maybe search on Google or on LinkedIn. PD, they think 11 to 50 employees. So mark in our range, that's 10 to 100. NICS code. This is going to be loans of some type. So we'll come over here. Mortgage and non-mortgage loan brokers. Seems to be, unless there's another, well, consumer lending. That sounds probably better. National financing, second trade financing. The problem with like small internet companies like this is, one, there's no technology option. in kind of the structured industry schemas, but also like one companies that kind of pop up quickly like this in technology. A lot of times it don't have a obvious or don't have an immediate NICS code. In the US, technically, I think you have to have one assigned, but I don't think it's public. Other non-deposit credit, second market, financing, real estate. We'll go with this. Locations affected, 1. Oh. The country is India. And then the thing is, I'm not sure where India falls from I think they're actually West Asia. Nope. Okay. I always have problems with the Asian, Southern Asia, the Asian ones, because they tend to be not intuitively what I expect. So Southern Asia is in here. Probably should add a Southern Asia one here, since we do have a lot of instances in India. 4.2, and then Southern Asia is 0.3.4. And we're concatenating both the major code with the minor code in the region, and it's not a great way to do it, but it's kind of how the data is structured. State, they actually had a state here, I think. It was here. Body Kushi. Totalan body. Is this, so let's see, is this a state in India? My geography is not as good as I would like it to be. So let's go find India, our list, and we'll see, is this in here? It is. This is a state in India. So IN-HR is our state. Secondary, there were no secondary victims, so we'll skip it, and that gets us through the victim section. The action is really easy. It is error, and then misconfiguration, carelessness, and this is a good point to talk about some of the schema, because I think that there is a actual definition for this. If we go and look at the Varus repo, if you look in the issues, there are a lot of coding style issues. I think we have one for cloud storage. Do we have any others for cloud storage in here? Because we want to try to code everything very much the same. And so this is an example of kind of a consistent cloud storage. Error, vector, we have vector unknown here. So we'll follow this. And then actor, so that's the only action. The actor is going to be internal. We're not going to have, say, variety. We don't, well, variety is really system administrator, because they were administrating the system, but it's really no motive, so because it's an error. And we don't know anything about job change, so mark that as unknown. And then our assets, go back up here and close actor. Assets, we have one storage. This really isn't a, we'll use a file because this wasn't a database. Sometimes these are something like a MongoDB database or such. But as far as we know, there was one storage bucket that was open. Operating system, not really applicable for cloud storage. Cloud, let's see. And we're probably going to change these because it used to be that cloud was based off of how the cloud was attacked. Now we really want to know about the actual storage. And so in this case, cloud hosting error. or not by attack, hypervisor, other cloud host, partner application, unknown. I'm gonna put cloud. I need yes in here is what I need. So this is on our list of things to clean up in Varus when we do our next cleanup, because it is known that cloud asset was evolved. It did not affect the outcome. And because it really lack of security process procedures by hosting providers. See, it wasn't the hosting provider, and it rarely is, right? That used to be the concern, is that your hosting provider from a cloud service was the security risk, but now it's really individuals. And we don't really know what area it was hosted in. We would assume whatever AWS region is closest to India, but it's not a big deal, and so I'd rather not guess at it. So attribute, confidentiality, disclosed. Yes, we know that because the person on Twitter looked at it. The amount really wasn't listed, but what did they say the data was? Okay. Andir or PAN cards. And Andir cards were those are like the Indian identification, right? Kind of like the equivalent of a social security number in the US, or a social security card. So this looks mostly like personal data. We don't really know the amount of customers from the look of it. It was stored unencrypted, very clearly, and was not abused. And we don't know about credit monitoring, and we don't have any partner data that was lost, that kind of thing. So we'll close attribute. This is targeted. It's opportunistic. The person looking for it was probably just scanning for open buckets. Discovery. We'll look at our example. External. And the variety is unrelated third party. And then, oh, no, this is correct because we coded this as an error. Then it's not applicable because of the error. We're not coding the discover, we're coding the action by the organization. And that goes back, and there's actually a coding style issue about that. And this brings up a good point about Varus. Let's see. Misuse. Where did I put this? Oh, here we are. So we'll go and look at this one. So when we code Varus, the reality is that almost all actions within a breach are a combination of some type of vulnerability and some type of action, right? There had to be, the action took advantage of some state of the system. And so the problem is we really don't a lot of times want to capture them. We don't, certainly for the DVR, we've never captured kind of the pairing, or in Varus, we don't necessarily capture the pairing. And this, sometimes causes confusion. When the attacker, when we code something as the attacker exploit a vulnerability, for example. Well, or misconfiguration, do you code the fact that someone misconfigured the system or didn't patch the system, and the attacker taking advantage of it? And the reality is we don't. And so the rule we kind of rely on is when there's a threat actor taking advantage maliciously of something, we tend to code the actions of the threat actor, even if there was a vulnerability that an internal organization caused, someone didn't configure something correctly. We code the actions by the threat actor because that's really what we're looking at. However, in cases where it's an error and there's no real malicious threat actor that caused the breach, someone just kind of stumbled over the data, whether it be an open cloud storage bucket or it be a spreadsheet published on on someone's website. They accidentally upload the spreadsheet of everyone's personal information, which happens. Even if someone accidentally runs across it, we don't code that action. We code the actions of the person who made the mistake to publish it, or however caused the breach by error. And that's important to understand when both coding and reading the DVIR, because it relates a little bit to how to expect things to be coded. Errors, we tend to code the actor as the person who caused the error, while everything malicious, we code the action of the threat actor that took advantage of the vulnerability. And so because of that, we've got that discovery method. We just did value chain. This is if the attack had involved other things. So if the attacker had to develop malware, had to distribute the malware somehow, done some targeting and such. But since this is from the perspective of the actor being the internal person who made a mistake, the value chain doesn't apply. And so impact, overall rating, insignificant. The company closed the bucket, made an apology, and that's it. Plus section, we want to say whether these are randomly assigned. Sometimes we have breaches that are assigned by priority. And for academics who might be using this data set, we want to record whether the breach was assigned randomly, and so coded randomly or coded because it was a priority incident. And priorities are things like breaches that are, have major repercussions or have, huge numbers of records lost. We want those in the data set because people kind of expect to see them and don't understand why something might not be in there. So we add the random and hit forensic measures. We don't know. The event chain is very simple. An error by an internal actor on a server led to a compromise of confidentiality, and that is it. It is common to have very short chains of one or maybe up to 3 actions. We consider short because the reason 3 is kind of a good dividing line is because 3 is something like social attack, dropped malware, which then stole data. It really kind of falls out almost as a single automated step, but it really has kind of 3 individual pieces. Anything more than 3 tends to be kind of advanced. Security maturity, we really don't know. And so this is validated. There's our first breach. And we always prefer to do, the web app is set up to store all the records to local storage. It's set to, even if you export them, keep a backup copy in case you lost them, but keep them in memory. But just in case, if you have a problem, it doesn't hurt to copy and paste this JSON into a text document. That provides kind of a second copy. It's not a big deal if you're only doing one, but if you're doing several of these back to back to back to back, it's kind of stings to lose, half a dozen of these. So we'll return and we'll do another one. We're going to close this one, which I am notoriously bad about forgetting to do. So let's go back to my issues list. We'll see next cell on top. And by the way, if anyone has any questions, feel free to ask. This is a good time to answer them. Oh, this was in Varus. Oh, and I closed the wrong thing. So I closed the Varus issue, which I do not want to close. So we'll reopen this issue. We want to close this one and go back to our issues list, things that I'm supposed to be coding, and we'll catch the next one. My goal is to get 4 done today. And then after that, we'll probably try to do some Tidytuesday analysis. So we'll go back to the coding style issues. Okay. Union Watchdog accidentally leaked secret emails from See, this is why we end up sighing a lot while we do this. Things like accidentally leaking your whistleblower emails. Okay, let's see what we got. Union Watchdog accidentally leaked secret emails from confidential whistleblower. Registered Organizations Commission official entered incorrect character and email address. Well, we know how it happened. Australia's Union Watchdog accidentally leaked secret emails from a confidential whistleblower in an embarrassing mix-up last year. So this article is more than 7 months old. That doesn't help. It's published January, so this happened in 2018. We'll remember that when we get to the timeline. Internal documents show the Registered Organizations Commission, which investigates. Yeah, like the problem is we would overuse it and it would show up at the top of analysis if we used duh for an enumeration, and I mean that's really not something we want. Is like, you know, top action, you know, duh. Okay, so the whistleblower who worked on an unknown union or employee association had expressly asked not to contact their organization amid fears their identity could be compromised. But in attempting to send an email to the whistleblower in May, mistakenly entered a single wrong character in the email address. The email, which contained details of the conversations and the identity of the senior official, was forwarded to a random recipient with the same surname but a different first initial. Jeez. It was still active, but before pleading with the recipient to delete the... Sent a second email to the address to confirm the account was still active before pleading with the recipient to delete the previous message. So forced to apologize to the whistleblower. Mistake to the official commission. Steps have already been taken to have the incorrect recipient delete the email. And to verify the... Okay, so if you're gonna like blow the whistle, maybe don't use the email. So you're a whistleblower and you're using your work email to blow the whistle. Like, you know, who do they think runs the email server? You know, like. Okay, well, I guess we'll do this one. This happened in May of 2018, so technically this should go into the 2019 data set. Let's see. GitHub, reference, summary, confidential email sent to wrong person. And so the interesting thing in like a breach like this is this isn't like a whole lot of detail. There's a lot of kind of fluff in here, but it actually is a pretty good amount from a coding perspective. So we know that the incident happened in 2018, May. We don't know the day, but the month isn't bad. Compromise happened in minutes, it seems. Actually, do we really know? Does it say how quickly they sent back? Senior official is forwarded to random recipient with the same surname, but initial of the rock would not say whether the recipient worked for the same organization as the whistleblower. Would not say. They sent it to the same address. Internal emails show how rock scramble to fix the error in the next morning. So clearly this happened in at least hours. It was discovered in hours and fixed containment. But it doesn't really say whether they actually got it contained. They say that they've really tried. Exfiltration, which was sending the email. And compromise, I guess, happened in minutes, seconds, because I mean, really not applicable because it's an error. So, but the data was sent hours, discovered in hours. In fact, I'm gonna remove exfiltration because I think it's disingenuous for the purposes here. We know that they discovered in hours and containment happened. Notification happened. Can I urge you please leave this wrote on the 11th, which was the day after, so we actually do know the day. It happened on the 10th. Apologize, send email. We don't know when they apologize. We'll just not worry about that. So the victim here is technically the Registered Organizations Commission, I think. Right? So, who is the Registered Organizations Commission? Do we know how many people work for the Registered Organizations Commission? We do not. Look it up on LinkedIn. Australian Institute. I mean, I know it's an Australian organization. Registered Organizations Commission. I don't think we're going to find a whole lot of information about how many people work for this organization. So, trade unions. Let's just suggest this is small. It is a government organization, so it's going to be 92. But we want to see if we can figure out where exactly it would fall under government, public administration. It certainly would fall under executive offices more than would anything else. It's not going to fall under legislative bodies. Parole, police, administration of human resource programs, not really. Human resource programs, environmental, air conservation, housing, economic, agricultural, space, national defense, international affairs. So anything in here about kind of organizational oversight, like, yeah, economic. I mean, would it be economic programs? Regulation and administration of communications, electronic and gas and utilities, creation of agriculture, regulation, licensing, inspection of miscellaneous commercial sectors. That sounds about right. So put that in here. Locations affected, 1. This was in Australia, which should be AU. And then Australia is, I believe, Southern Asia. Well, no, it'd be Australia, because these are by continent, aren't they? Oceania, that's what it is. So 009053. And then state. It's a national organization, so I'm going to leave state blank. We're running secondary victims, and that gives us our victim information. Action. This is a fun one. Error. Missed delivery. Carelessness. And there's everything that happened. Actor. Internal. I mean, it doesn't really say. It's a internal person. Motive. There was no motive. This was unintentional, and no job change. So, let's see, we can probably close down actor. Asset. This was a mail server that was involved, and 1. The operating system and the rest of this doesn't really matter. Attribute. Breach the confidentiality. Data, 1 email. And this is, we'll say, I think secrets would be the best way to code that. Because secrets is going to be things like internal data would be internal data about an organization, like network maps or things like that. Secrets is information that the organization doesn't want other organizations to know about. And so I'm going to say secrets was of the closest equation would be customer. It was stored. It's not captured in transit anyway. Data abuse. It's not really known because we don't know whether the person deleted it without looking at it or not. Or whether they told the company or anything along those lines. So we'll close down the attribute. Discovery method. Does it say? But in attempting to send an email, we sent the wrong email contained. It's forwarded to the wrong recipient. The rock would not say whether the mistake recipient worked. It'll show how the rock scrambled to fix the error. Send a second email. Yeah, and I've caught an error. It sounds like they detected it internally. It wasn't the person that caught it. Internal other. But I mean, it could have been the other person that they were communicating with. You know, I'm just gonna go with unknown because I really don't think that we know enough to determine whether it was discovered internally or externally. May have. Okay. Value chain, again, this is another error. So we don't really have a value chain. Impact. Oh, insignificant to the organization. Plus, randomly assigned. Again, this was an error involving an internal actor at the organization. Using a mail server to compromise the confidentiality of a single person. And so with that, we can check another one off. Again, we're going to copy it and put it into a empty document over here. We have it stored, and just in case something goes wrong. So come back here, close the issue, and we'll go back to our list, and we'll do a third one. How are we doing on time? Yeah, hopefully we got another time. If we get 2 short ones, we should be able to get 2 in before the end of the hour. Man pleads guilty to skimming personal bank information from ATMs. Yeah, let's do this. So these used to crop up a lot, but they really don't happen near as much anymore. At least not here. At least from the number that I see when coding these. Maybe other people are getting assigned these skimmers. A Romanian man in the United States illegally see, we've got our victim country for once. And this is where you do get them, is sometimes these are pretty common international crime group type thing to do these skimmers. Romanian man in the United States illegally pled guilty Thursday to placing skimmers on Kansas City ATMs. Devices are used to illegally gain. We know what the skimmer is. Was arrested in April after police discovered an ATM at Quick Trips in Olathe and Riverside. He was arrested after they tracked him down. Yes. There were 15 unauthorized access devices and 78 re-encoded magnetic strip gift cards. After illegally obtaining the numbers, criminals transfer them onto gift cards. Authorities entered the United States from Mexico last year. Okay. So what do we know? This happened in 18. So September though. But that still would fall into the 2019 data time frame. So put myself on it. We'll mark the. Oh, somehow I lost my issue. There we go. Put in a new tab. So we'll get our GitHub issue. And this was confirmed. I mean, they went to jail for it, so was convicted, I guess, at least. Summary. So confidence high. Timeline. Incidents occurred in 2018. We don't know how long he was doing it really, and we don't know the exact time. Discovery happened. We don't know. Once it was discovered, it only took. Let's see, what do they say? They discovered it in. He was arrested in April. Pled guilty in September. Really doesn't say how long. It's another news article here. Maybe this one has more detail. And we'll put that over here. Put it up in the news as well. Man was caught. Pins. 15 otherwise. That's the same thing they said last time. April 7th, the device was discovered. Surveillance video from the Quick Trip in a nearby restaurant captured the people doing it. Later, the suspect returned. After starting an ATM for an unusual amount of time, the suspect bought food and left the store. Same day, another skimmer was found at another place. Okay. Acted on a hunch. Created a document. Decided to check motels in the area. To find the picture, he found the vehicle had been serviced on March 30th. So, search the Audi. Okay, so it almost looks like the same day. So I'm going to mark a day or two. So the discovery took, we don't know how long, but containment took maybe 2 days. Because they found him pretty quickly at the motel. Yeah. By the way, I like the concept of a hunch, as in, this is how this always happens. Like, every time we see this, it works this way. So, oh yeah, I know, puppy. Okay. Timeline, the victim. Quick Trip. How many employees does Quick Trip have? Probably a lot, to be honest. And so when we're coding things that have a number of locations, 805, our employees 22,000. So 10,000 to 100,000. There we go. 10,000 to 25,000. I mean, 22 sounds pretty low unless they've been shrinking, which I'm going to go with 25 to 50,000. It's a more likely estimate on the assumption that they are growing. Industry, gas station. Well, there's extraction, which is not really what I'm looking for. Nor drilling, nor pipeline construction. Gas machines, air pumps and gas presses. Oil manufacturing. Should be down in, yeah, here we are, gas stations. Gas stations with convenience stores, which are apparently separate. Yeah, okay. Locations affected. It said there were a couple. Come here. So he had 15 unauthorized access devices, but they really only found 1 or 2, right? Found another Quick Trip. Okay, so here they say 2. Let's see. Placing skimmers, device covered on. So 2. Looks like 2 locations in the United States. Our region. And the state is Kansas City, Kansas? Or Kansas City, Missouri? Maybe we'll start in Kansas. Well, I mean, Olathe is Missouri, right? Nope. It's in the Kansas side, so we'll go with that. Okay. No real secondary victims, so close down the victim. Now actions. These would be physical. And we get to go and actually hit the skimmer. Vector, victim, public area. Or actually, there's grounds that's in there. Victim grounds, so outside. They didn't really have to infiltrate, but they use this to exfiltrate data. And then we can close down the actions, because that's really all that was involved. External. That's when we get to actually choose some fun stuff. You don't sneak in through Mexico from Romania to plant skimmers and not have kind of a structured plan there. This was not a one-off thing. Definitely financial. Romania. And I don't know what region Romania would fall into. So let's go check that out. Maybe Western Europe? Let's see. Nope. Okay. See if we can find Romania under M49. Oh, yeah. Latitude does not help. Country. That just takes us back here, which doesn't tell us region. Lots of regions in Romania, which is not necessarily what we're looking for. Region. Okay. So, what region is Romania? Here. It's in this one. 49, numerical code, similar to the... Well, they give it as an example, but they don't... That doesn't help. Let's see. You see here. Really, I should probably save this site since it has the country to region code. So 642. Then we can go back over to where we're looking at regions. And we can do 642 falls under. Oh, but this may have been the country code. This may have been the, that's the 3-character country code, not the region code. That's not helping. So M49 has country codes as well. But they don't. 642. Let's see. M49 642. We know it's here. This 642. We know it's Romania. So what region does Romania fall into? I checked Eastern Europe, didn't I? Apparently not. Southeastern Europe, maybe. Okay, well, let's try, we'll put in Southeastern Europe then. Romania, South. Oh, there is no Southeastern. Okay, so Southern Europe, 039. 039, and Europe is 150. So 150, 039. And then name, we don't really know the actor name. So we'll close that down. Asset, total assets, 2. Variety, these were terminals. They were gas terminals. Oh no, they were ATMs, weren't they? ATMs, amount 2. Oh, and so if these were ATMs, then the action, I was thinking they were gas terminals, but if they were ATMs, they would be inside the building, very likely. Which means that we should have done victim public area instead of outdoors. So locations were in the United States. Cloud, no. 2 assets, like that. And the attribute, the integrity of the devices was lost. See. Transaction, hamper, hardware tampering. And then disclosure, yes. And we know about, they said 78 cards, I think. They stolen at least 78 credit card numbers. And so, uncover internal payment. There we go. So there's our attributes. The discovery method. Said, does it say who discovered them? Was it the organization or did someone just find them? Charged. Follow. Please say the financial. Dozens of people may have been affected. Number, and then transferred on. Okay, investigating led. Placed. Well, how did they discover them? Were discovered. It doesn't say. It doesn't say. And the big determiner is if the organization discovered it, if the Quickie Mart discovered it, it would be internal. But if the if a customer discovered it, it would be external. So we'll put unknown because we don't know who discovered it. Value chain. Non-distribution services. So I'm going to say that the actor was smuggled into the country. Development, they really, let's see. Skimmer, put physical skimmer here. Targeting, they really didn't have any targeting. Distribution, they didn't need to distribute, the person was there. Cash out, see, is there credit card fraud? Direct stole money. So I guess they were stealing ATMs, so they were probably gonna just directly steal the money. And then we don't know how they were gonna launder it. So we've got our value chain, and then the impact. Insignificant. They don't even know who had what. They just found the guy with the cards. And then subsource. This was a random assignment. The actions were a physical action by an external actor on a terminal to compromise its integrity. And then the physical action of skimming by the external actor on the terminal to compromise confidentiality. And so mark this as validated. And that's our 3. And let's see, what time is it? 11:55. I'll do one more. And then we'll switch over to some analysis. And so close this issue. We'll return. And we will code one last one. Back. And this one is not a random assignment. PHI DBR 2019. Elmcroft Senior Living responds to data security incident. Woohoo. Okay. Open up a couple of references. We'll close down our old references. We'll see what we have here. Elmcroft Senior Living Incorporated, a Louisville-based company which previously managed the Elmcroft community portfolio, has responded to a data security incident that may have exposed personal... Okay, that's great. Community which operated assisted living. I don't care what they do. I mean, does it really take an entire line of what kind of facilities they operated? Is that relevant? Because committed to make every reasonable effort to safeguard your data except for losing it, and provide monitoring for those impacted. No cost for 1 year. So let's see. I think it's under attribute, confidentiality, credit monitoring. Yes, for 1 year. Okay, so what actually happened? Became aware of an unauthorized third party accessed its servers. Well, yeah, that's a little bit more than nothing. 2 days earlier, and immediately terminated the third party's access. The company has notified local and federal law enforcement. Include names, birth dates, social security numbers, former customers and employees, both. Okay, great. So they don't really want to talk about what exactly happened, apparently. Okay, let's see. Does this one have any more data? An unauthorized third-party access data. That's what we got before. Did not specify the number. Manage a portfolio of more than 70 facilities. That's not helpful. Data security involved. May 10th said the company became aware of it on May 12th. That's actually not bad. 2 days for discovery. And it looks like, a unapproved login, so probably stolen credentials. Said the breach was thought to have occurred while Elmcroft was transferring information from its computer servers to the servers of a new operator. However, he said the breach was unrelated to copying the data. Thought to complete, notified. So probably they created an account while doing this, and the account got breached or something. Notification letter. So said the breach was originally thought to have occurred. Said the breach was unrelated. Okay. So they were doing something at the time. It didn't have anything. Okie dokie. Let's give this a shot. It happened in 2018. Oh, so this goes in the 2019 year. It's confirmed. The issue is number 11549. We have 2 references, either one of which tells us a whole lot about what happened, but amazingly enough to actually make them determinations. Summary, account used to access personal information by unauthorized third party. And we're not going to know a lot about the actor, right? If the third party had been an actual employee, they would have said something. And there'd be information about how they arrested them and nothing happened, that kind of thing. If it's just third party, it means it's someone, it was an account that they didn't really know. But we've got some dates. So it started on May 10th. And then we actually don't know a lot. They don't say whether the data was taken or not. They just know that they potentially had access. So we don't know about compromise. Time was unknown. Exfiltration time. We don't know if exfiltration happened. Discovery time was 2 days, it sounded like. It's on the 12th. This one over here. And they terminated the account that day, so containment happened in at most hours. So the victim. This we should know because they're listed. Elm Cross Senior Living. This was in... Let's see, we'll close timeline. Let's find out who Elmcroft Senior Living is. No Wikipedia page means it's a little bit harder to figure them out. But we can probably guess from their LinkedIn. Ooh, 5,000 to 10,000 employees. But only 1,000 listed here. So let's put them in the 1 to 10,000 range. Let's see, what is assisted living? Let's see. Say homes for the other residential care facilities. Homes for the elderly sounds like the most accurate enumeration for this. In the United States. And this was Kentucky, right? Oh, region, yeah. Kentucky, US. Oh, US, QY. And no real other stuff. Action sounds like hacking. Use of stolen credentials. And we don't know the vector. They don't say whether it's like a VPN or remote desktop or email. We know it's to infiltrate. But we don't know if there's any pivoting going on. And that's really all we know about. And then the actor, it's external, but again, we don't know. We don't even know what the motive is. So it's not really clear about whether they stole anything. We are going to have to mark a country, though, because that's a required field. So we'll mark unknown. Then the asset. Again, we know it was a server because it was logged into. That's about the only thing you log into directly. It sounded like only one, but we don't really know whether it was the mail server, the VPN server, or anything like that. Then the attribute. This is where it gets fun, right? Because confidentiality disclosure is potentially, but they don't really say. And the variety was personal information. I don't think they said anything about medical information, did they? It's at the top of this one. Isn't it? Names, birth dates, and maybe social security number, and health information. So we will go with health information because that's kind of the customer, and then I think on the other one they said employee as well. State, stored. I'm going to go with stored unencrypted since they know that the person had access to it. Data abuse is unknown. And we know that there's an integrity loss because of the use of the stolen credentials. Well, no, excuse me. We know that there's another type of data, which was the credentials that were used to log in. So we know that medical data and credentials were stolen, but we don't know the actual amount. So close down the attributes. Discovery method. Sounds like it was internal, but they don't say how. Value chain, we don't know a lot about what the attacker did, and we don't know whether they took anything. So we really don't know. Impact. Significant, they offered monitoring for everyone, and that was about it. Then, this was not a random assignment. This was a PHIDBR assignment. And PHIDBR stands for Protected Health Information Data Breach Report. Off and on, we've done kind of a report directly on data PHI information or healthcare information. We don't do it all the time. It depends kind of on our schedules, but we try to do it every once in a while, every year or two. So what happened here? Hacking action by an internal actor on some type of server to a breach of confidentiality. I'm only going to code the one action because we don't know that they took action on the data that they had access to. So it was validated. And we're, victim industry. I thought I put in victim industry. Did I put in the wrong field? I did. I've done that before. Put in there and put 1 there. So, and by the way, this is a nice way to see if you make a mistake in something that is validated against the schema, it will let you know. Save, and then we have our 4th incident. Okay, I'm gonna put a new file over here, save it, and return. Now I've got my 4 incidents, and so now it's time to switch gears. So I'm gonna pull this stuff off to the side and bring over some other stuff. So let me find the other thing I need to bring in. Go. I'm going to close this issue here so that it's off the records. And if you'll bear with me a second, I'm going to post a tweet real quick saying that I'm switching over. And then I'm also going to save these records out and store them in VCDB. That way they are available. And really all it takes is we export them, and I have to unzip them. And then, let's see. Do I have a window open? So the biggest part is actually pulling the VCDB repo and getting it up to date, because I added breaches yesterday, and so it's rebuilt the data. And then from there, all I have to do is I have to copy the 4 incidents we did into the data set. Put it into, and we're going to drop them into, I'm going to drop them into the submitted directory in VCDB, and git add data JSON submitted to the repo, git commit for breaches from today's stream. And we'll push those in the repo, and we've got them up to date. And then that will rebuild tonight. And so let me go and post here on Twitter that we're going to switch over and do some analysis. So, I'll post the link so that people know where to find us. And add that here. Okay, so switching gears. What Tidytuesday is there's in R, the programming language, there's a package or set of packages called the Tidyverse. They kind of follow the same rules and the same process for dealing with data. And so you can download R at I think it's project.org. And then we're using this right here is a tool called Interact. And what it does is it runs a Jupyter Lab analysis environment in a single app and makes it a little bit easier to deal with. To do the analysis or to run R in a Jupyter Lab environment, you're going to need something called the IR kernel. And you can get that here, if I can copy the link off correctly. And then once you've got this all installed, and you have to do this part at a R console, you could do it at a command prompt or such. And then once that's installed, you'll have an IR kernel option in Jupyter Labs. And then we're going to use a lot of tidy tools. So the first thing you may want to run in your environment is install.packages tidyverse. And that will install a bunch of different packages. They're all kind of related. But I've already got them installed, so I'm not going to do that now. And so this is what we'll get started with. And so what Tidytuesday is every Tuesday they put out a data set at this GitHub link. And they give you the opportunity to just play around with it and explore it and kind of see what you can find. And it's just a chance for people to kind of explore their own data or explore data and kind of practice their data analysis skills on a public data set. And so the first thing we're going to do to make this easy is we're going to import Tidyverse. And you can see it's importing a bunch of things, ggplot, Tidy. These are all packages. And the most important one is probably dplyr. And I'll explain why here in a minute. But dplyr gives us a couple of verbs and then that are used for our analysis. And one of the things that is imported and but not explicitly defined, is magritter. And magritter is a symbol like this. And what this means is if you have a function over here that's a, and then b, function b, this is the same as saying run function b with function a as the first input. And this is nice because it lets us chain these together, commands together, and then it does kind of the nesting for us, so we don't end up with this really complex, ugly nesting as we do our analysis. So we'll do this as like kind of like that. And so this is the magritter operator. The other thing that's captured in here is our language, which lets us do some things like not having to quote variables and such. But you don't have to know a lot about that. This is kind of just works. And so the first thing we're going to do is we're going to come over here and we're going to grab the request here, the data that we're going to pull, and we're going to download it. And what this is it's going to read in a delimited file. It's going to use the pipe as the delimiter for this separate file, because clearly this isn't comma separated, it's pipe separated. And it's going to read it into a data frame named Simpsons. We see it gives us a little bit of information. See, a few parsing errors, which is surprising. See, by the way, you can find these. They're all over Twitter with nice links. 20 parsing errors isn't a whole lot. Expected 6 columns, found 5, and that's sometimes okay because it just means the field isn't there. So we'll find out. We have a couple of different columns. We have the season, the number, production code, episode title, guest star, role. And so let's take a little bit of a look at what these are. So the first thing you can do, and it comes from dplyr, is glimpse. This is kind of the first thing I do anytime I get a new Simpsons, plural, get a new data set, because it tells us a little bit about it. And so there are 1,200 different rows in this data frame. And so this is a table of 1,200 rows and 6 columns. Number 2 space 31002 space, and the U20 is obviously a space. 13102. So yours probably 13. I wonder how that works out. And then the guest star's name, episode title, then the role they played. And so the first thing when you do a data set is you just stare at it and you go, what in the world am I going to do with this? And that is pretty normal. I've spent days staring at data sets, depending on the complexity, just thinking, how am I going to get started? You know, what am I going to do to give this just a beginning? And it's always important to just do one thing, just one simple thing. And using the glimpse is kind of your first step. In fact, because we imported this library up here, we don't actually have to specify the library. We have access to all the internal functions directly. So we can just do glimpse. We can actually call libraries that are installed but not imported by doing the library name and then foo, that kind of thing. Oh, I exited. I've had this problem recently where this is exiting more often than it should. So I think that my kernel died on me. Yep. Restart. Found the most reliable ways to switch kernels. And so we'll start at the beginning and we'll just rerun all this stuff. Mark that as not run. And then runtime cells run all. It's going to go through and it's going to run everything. So let's just count the number of guest stars. One of the way we could do this is so do I even want to show the hard way? Probably not. And so in distinct Simpsons and then guest star. Oh. Guest star. Oh, so 700 unique guest stars, assuming that the names are all correctly spelled and all that stuff. You know what might be fun is to count how many guest stars have occurred. Who has the most guest stars? So Simpsons. And we'll start by using the pipe here, right? Because this takes the data frame and it puts us in as the input to the next function. And this is when we'll start using the dplyr. Well, we're not going to even use the dplyr words. We're going to use a simple one from this. And so count guest star. And then, I mean, this isn't really helpful because it lists them all. So let's actually do this. Arrange descending in. But, you know, I don't like in as a as the number, the count, because I always think of in as the sample size. So I'm going to rename x equals in up on this line, and then we're going to count descending x. So Marcia Wallace, it's 156 individual appearances. So that actually begs a question. And, you know, I don't want to look at all the stuff that's making my data frame really ugly. Ooh, and there's a parsing error here. Weird alien coding. So I know I saw someone somewhere where there was a parsing issue. So maybe I can find what they did to fix it. Let's see. Look for a pull request that may help us fix this. Here. May need to change the quote character, set the quote character up here. Quote equals. I bet this is not what I think it is. Oh, remove the quote character is what we need to do. So let's try that. Oh, see, no more parsing errors. Yay. So we'll look at it again. Now we have 1386. We fix those rows. And we got a better thing. And we only want the top ones. So top in, say 10 by x. Those are our top 10. And so Marcia Wallace seems to do this a lot. And so let's give a look at what she's doing. So I'm kind of curious, is she doing a lot of different characters or just one? So let's filter, and this is one of our verbs that we can use. Filter guest star equals Marcia Wallace. And then we'll count again. And this time we'll count role. And then rename x equals in. Oh, and we made a mistake. Guest start. Again, I almost said that the first time. And she always plays Edna Crabapple. Oh, we notice an interesting thing here is that there is probably one line per episode per guest star. and that in some of them there's a semicolon, which maybe means there are multiple. So that's interesting. Actually, up here it's interesting. There's 2 spaces there, but I don't see the 2 spaces here. Did I misspell Marcia Wallace? No. Okay. I wonder how often that happens. So let's see if we say, let's start with the same data set, but mutate. Then we're going to look for whether, let's see, multiple roles equals stringer, string, I think it's contains, nope. So we want to know whether a string contains a certain character. We could do it with a regex, but it'd be nice to just match the maybe string locate. Let's look for the stringer cheat sheet. Stringer cheat sheet. And this will give us a little bit of information. Stringer is what we use to play with strings. Download it. Actually, can I just look at it here without downloading it? Oh, of course it's going to want me to download it. Let's see. We'll just open it locally then. Let's see. So what do we have here? Detect matches, detect the presence of a pattern match in a string. So detect is probably what we want to use then. Detect. And then the pattern is going to be this, and the string is going to be roll. And this returns just a logical, which is what we want. Then we'll glimpse again to see what we got. Now we have a true false. And so what we can do is, again, we'll count multiple roles and rename x equals in. So we have 68 cases where a single person plays a single or multiple characters. And what that kind of means is our data is a little bit dirty, right? Because we want one line for every occurrence. Even if it means, because really this is not a single occurrence of Edna Crabapple and Miss Mellon. It's one occurrence of Edna Crabapple and one occurrence of Miss Mellon. And so we kind of are going to need to work on our data a little bit then, because we want to split those out. And so what should do that is Simpsons. And then what we need to do is we need to replace role with a string. And so how are we going to do that? So we're going to have to nest the string. So Simpsons. Now I have to remember all my syntax off the top of my head. Mutate role equals stringer string split fixed, and we're going to split it the role at the colon. I just want to double check. Well, we'll give it a try first and see what happens. Yeah, it didn't like that. String pattern in equals in because it wants to know the number of splits. Split the vector of strings into a match of substrings, split occurrences, also strings, but returns a list of substrings. see, this is gonna also string split to return list of substrings. So maybe we don't want fixed and we just want to use string split. Whoop. Can't change the output. Let's see. And so what you notice now is that this is a list. And so in the very first column, if we do, let's see, head 1, so we're just going to take the very first thing off this. Role is now a list with the first item in that list has two items inside of it. It's kind of like, you can think of nested JSON, a list in nested JSON where the first item in the list is a list itself. And the reality is R is not particularly happy with dealing with nested data. It's not a common way for things to work. And so it just doesn't like it a lot. And so what we'll do is we're going to want to spread this out a bit. So I'm going to say head 2 for now, just for an example. And then we're going to unnest role. And now, instead of before, this was all on one line, right? And now it's on 2. And let's see. I also don't like this Unicode character in here, right? What is Unicode 2013? Or actually what would be even better is if we dealt with the Unicode up here in read delimited. So maybe reader Unicode. So we'll look at a little bit on the documentation, how to deal with Unicode. Maybe in reader. Let's try UTF-8 encoding and see if we get a better decode. Come down here and run this. Nope. What is this character? This is the problem, is it's an English dash. So if I want to replace Unicode character, how do I want to do that? Well, if this didn't work, there's no point in leaving it in there. I can gsub, I guess. Let's see. So can I just replace it? So what we've done at this point is we've separated these out, and now actually where if we look at this, we now have 13 up and remove the unnest. I want that. If we do this, we can look and we have 1477 instead of the 1386 lines. Right. The next thing to do is to get rid of the Unicode character in the number, and so mutate number equals substitute match U2013 for, just put a dash in there, and we want to do that in number. Let's see if that fixes it. Nope, didn't match correctly. There we go. Didn't need to escape it. And so now you see we've fixed this production code. And so now we kind of have the data set we want. And so I'm going to take this up here and I'm going to put it underneath our import. And I'm going to save that back out so we don't have to do that again. So we've got kind of a cleaner data set now. And so it'll be interesting to see who has kind of showed up over time. See, there's a lot of people here, but I bet we could remove the ones that have only showed up once. And so let's see who, has showed up the longest apart. So we'll start with Simpsons. And we're going to be operating on individual guest stars. So, shoot. Problem is, but I think we can order the number. The number is really not... see, we don't actually have a... We don't have a good determiner. Let's say that multiples, we'll just go by seasons. And in fact, what happens if we try to turn season into a number? So let's look at the number. What values do we have here? Simpsons, I thought we had seasons. Go back up, season, okay. Great. We have everything except we have movie. That's helpful. And that's why this is getting coded as a character string. Okay, so what we'll do is we'll remove the movie. Filter, this is another one of the verbs. We're going to remove everything where the season does not equal movie. And then the next thing we want to do is mutate and make season as integer season. And then we're going to group by guest star. And what that does is anything we do after the group and until we ungroup happens individually for that subset. And so if I do something that says, say, mutate length equals, one second. So length equals max season minus min season, and then we're going to filter and only get things where length equals or season equals max season. We only take the top and the bottom. Season equals max season, or season equals min season. That's not an equal sign, is it? And we need to use double equals here to make this work. So do this. And we should get 2 records per person. So we're on a group and then we'll look at it. And then we actually, if one of the things we want to do is if filter length greater than 0. So we'll filter for length is greater than 0. Because if they were only there one season, we'll just skip it. So because we're looking for people that were there for multiple seasons. And then this line will get, so mutate, change that. This line will get rid of anything but the first and last season. Actually, you know what? I'm not even going to include that because I think we can have some fun by just doing this. And so now we're down to 309, and one thing we could do is go count, or summarize x equals n distinct guest star. And what this will do is it'll tell us how many guest stars we have that were there for multiple seasons. 129. Nice. So let's maybe try to visualize this. And we'll actually just filter to the top ones. So we'll take a look at the data first. It gives us an idea. Length 28 seasons. And so what we want to do is we want to find the top in actors, say the top 10 actors by length. And so what we might do is we might nest a bunch of the data. So nest the individual season. See, we should only have 2 per. Well, but we got the multiple roles. That's a problem. So, well, one of the things we want to do up here is, well, we're gonna actually need to group this again. Group by guest star and season. And then slice 1, then ungroup. And what that makes sure is that we only should have 1 per person. It's going to cause roll to not be accurate at this point because we're dropping rolls, but we weren't going to look at rolls anyway. So glimpse this. So himself. See, I wonder why we dropped Edna. So guest star in season size 1. So I'm wondering where Marcia Wallace went. We may have just pulled an earlier one for her, but we'll see. So filter roll equals Marcia Wallace and see what we've got left for her. And she dropped off the map. I wonder why. Because she was in it before we put this in. So let's see. It doesn't seem to think she was in it. I thought she was in it. Oh, because this says roll. This should be guest star. So she's got a bunch in here, which is not really what we want. Oh yeah, because I didn't slice 1. Okay, yeah, that's why. So that's okay. Actually, so I was thinking we'd filtered the top and the bottom, so we had the first and last, and we don't. So that's okay. We'll just nest these. So we're gonna nest. What do we want to nest? Just really everything but the guest star, really. Guest star and length. Season, number, product, production, code, episode, title, and roll. And this gives us a single row per guest star. And we're going to use this to filter out the top 10. So top in by 10 by length. See that? And we have a tie, so we get 11. But now we have the top 10. And we can unnest the data. And we get back all of our other fields. And now let's do something visual with it. So ggplot is our visualization library. And the same way the pipe pipes it into here, the first argument to this is the data. So ggplot, and then geom. And geom stands for geometry. In this case, let's do a line. And then AES is aesthetic. An aesthetic maps the data to the geom. And so in this case, we're going to say that the x-axis we want to be the season. And the y-axis we want to be the... we're going to arrange the data here first. I think it'll do it on its own, but arrange the data by guest star and then by season. And then y, we're going to make the guest star. And let's just take a look at what those two lines do. So good, we've got some lines showing the things, but this is by guest star, so maybe we want to do by season first. And so now we can kind of see the people who have guest starred the longest, from season 1 almost to season, or all the way to season 30. And that's a good point, right? Because 0 doesn't make sense. There was no 0 season. So let's X is a continuous scale. Let's set our limits to 1 to, NA means just whenever the data says. Oh. Scale X continuous. Why did it not give me limits of 1? I was expecting a 1 here, not a 0. What did I do wrong? Let's see. Span equals 0, 0. Maybe it was just the expansion. And I don't like those ticks on the end, so anything visually that you want to do, you do with a theme. So we'll do axis.ticks equals element blank. So now we don't have the ticks. And I also don't like this gray background that much. I'd rather have background and then the grids, axis.grid x.major equals element line color equals gray 85, kind of the de facto color when you don't have anything else to use. And the reality is that for the Y, we've got these lines, so we really don't need any kind of grid. So do element blank, and I messed something up. Axis grid dot major dot x. It may be dot major dot x instead of x dot major. I tend to make that mistake. Oop. And then there shouldn't be a comma after this as well. Oh, because this is the panel. Yeah, that's why. So the grid happens on the panel, not on the axis, even though it starts at that. So there we go. And I don't like those breaks. So let's set our breaks to every 10 years. Sequence from 1 to... Well, sequence from 0 to 30 by 5. I think would make sense. Yeah, that looks a little bit better. And what was I going to do? Oh, so we've got the lines, but it would be interesting to see how many times they show up. And so let's add a point. And so now, every time there's, right now this is a bunch of line segments from point to point to point. This will put a dot on each of these every time these people guess it. Oh, and we see that we're cut off here, and that's because of our expansion. So we're going to want to expand maybe a little bit. See, what if we expand by 1? Yeah, let's expand by 0.5 so we don't get that 0 in there. There we go. That looks a little better. And now we've got kind of an interesting visualization. Ron Taylor has only guest starred 3 times, but showed up a couple... showed up twice early and then once later on, a much larger span. On the other hand, Garcia Wallace has basically shown up every year other than Looks like 26th through 28th. Kelsey Grammer, I think who plays Sideshow Bomb, has shown up regularly. Joe Mantagina? I don't know. I am not good with names. I apologize. George Takai has showed up several times. And so we can see how often these people are showing up. Yeah, so that's the interesting one. And I was thinking about that. The question is what we want to sort them by. And because we're not really sorting we're wanting to sort by the first appearance. And so what we actually have to do is we're going to have to change guest star into a factor. And we'll sort by guest star. But guest star is going to have to be a factor, and it's going to have to be sorted by the first appearance. And so we're going to have to come up here. And this may be the last thing we do before we call this. And so instead of arranging these, we're going to mutate. What would be the best way to do that? Guest star equals, and actually this is going to be an opportunity. I'm going to pull up another cheat sheet because we want to look at the 4cats cheat sheet. Actually, the best way to do this will be to actually, when we nest them, before we nest, so I could do it as, you could either do like a per function. In fact, per might be an actual interesting one while they're nested. Mutate first appearance equals per, and I want to return an int, so map int, and we're going to do it over the nested, and it should be .data. I think it's called data. We'll glimpse at this point. This is going to fail when we do this, but that's okay. Oh, but why? Oh, because I didn't fix. Gotta do this. Gonna remove this. It's got to actually parse. Yeah. So it's data. So across data, what we want to do is take the minimum of data season. Oh, and this should be a .x, not .data. And so that should give us the field we need. And so if we take this and move it down here, what did I do not to parse? So 1, 2, 3, or 1, 2, 3. Yeah, I need another one here. First appearance, season 1, season 2. Okay, and so now we can arrange by first appearance, then by maybe length. Is that what we want? Because that's still in the nested. I mean, really don't. Yeah, so let's put this on. We'll arrange it here, length, and then season. And what we're going to do, well, before we unnest, let's arrange by first appearance and length, and then mutate guest star equals, it's a as factor, I think, right? FCT as factor. We'll maybe just factor. Factor guest star, oh come on, star levels equals reverse. No, it'll be fine, I think. Just doing levels equals guest star. And the reason I'm kind of questioning right there is because sometimes when you order it, what I expect is that this is going to be backwards of what we actually want, because it's going to put the earliest ones on the bottom, and we tend to read top to bottom. And so a lot of times you want to reverse the levels if you're using them on the y-axis. Oh, I guess it's just a normal. Yeah, see how it's reversed? So if we want to read it from top to bottom, we're going to do actually on length, and then I'm going to do it by guest star, so there's some order after that, which would be name. And we could do, like, we could use this to calculate in appearances. So appearances equals in distinct season, or just in, really. In row of dot x. And then we could do by count ascending appearances, and then order it, and then we're going to reverse the levels so that we get the ones we want on the top. So the fort, and then what's Kelsey grammar? 1, 2. I wonder why these didn't go in the opposite direction. Before I fix that, though, I want to fix the labels. So x equals guest star. We'll call it guest star. Y equals season. I mean, that's probably what's already labeled, but it's kind of good to put on. Title equals we'll say longest running. Then subtitle equals I don't know. A lot of times it's nice to have a subtitle, though, because you can use it to explain what exactly is going on. Dots equals seasons appeared in. I'm a fan of using subtitles. Oh, you got something messed up here. Oh, title is not a capital thing. There we go. Dots equals season. No, actually, I think maybe we'll just do this under case. Then again, I don't like having these kind of the middle of the axes. That never looked good to me. So, let's see. Sys dot title dot x equals element text. Hdest equals. It's always backward to what I think it's going to be. So I'm going to put 0, and then sys.title.y equals element text. Vjust equals 1, I think. So we got 1 in the right spot. But I have them switched. So this should be x, and this should be y. So this is now aligned where I want it to be, but this is not. So why is it not aligned? 'Cause, I mean, it aligned this way, didn't it? Yeah, okay. It's relative to the data. So 0, 0. Okay, there we go. And so I think you might be able to also use a line, like a line equals left or line equals right. That puts us near the end of the hour. I will post this notebook as a gist for anyone that wants to play around with it or give it a shot. But this is just a really quick and easy look at some data, and it's an opportunity to play with the data. And really, we did a lot here, right? This is a decent amount of code to parse through all this, and we made an okay looking chart. It's not the most beautiful thing, but it tells a story. It tells the story of who has been around the longest and when they appeared. It's enough that we can explain things, or we could communicate something from the data that, remember when we started, we looked at and we said, what in the world is this? So anyway, thank you everyone for coming. I appreciate sticking around. I think this may be my longest stream to date, and so I appreciate it, and I will see y'all later. Have a good night. Probably the next stream will be Thursday, hopefully at the normal time at 10 o'clock Eastern, doing VCDB stuff. So thank you very much.